Hello and welcome back. We are venturing into section 6.2 today, and in section 6.2 today we're going to be talking about rational exponents. The problem with rational exponents are that it's fractions, and I know and you know, we all know how much we all hate fractions. And so as we go through this, be ready to smile a little bit and know that some of our skills aren't as good as they need to be, and we're going to work hard at it, and if we work hard at it, we know we will be successful eventually. When we're talking about radicals and simplest forms of radicals, what we are talking about is one of the things is you can't have radicals, or you can't have square roots on the bottom of fractions, and that will make things a little bit difficult for us sometimes. And also you can combine certain things, and so we're going to kind of skip over these definitions and just move on to the properties of rational exponents, and maybe that will make a little bit more sense to us. So the properties of rational exponents: a to the m times a to the n equals 8. Well, that's the same property we just learned, but it's the rational exponents, not just regular exponents. So we're going to add 1/2 plus 3/2, and we get 4/2, and you end up with 4 to the 4/2, or 4 squared. If it's a to the m to the n, well, we're going to multiply those two things together, and you have this situation here. If I multiply 5/2 times 2, I end up with 2 to the 5th power. In this one, the m kind of goes whoop, whoop inside of there. And so 16 goes to the 1/2, and 4 goes to the 1/2. And I know some of you are saying, well, why didn't you multiply the 16 times 4 first? Because it was in parentheses. Well, that's a great idea as well. Either way, you're going to end up with the square root of 16, which is 4, the square root of 4, which is 2, and you get an 8 as a result. A to the negative m, see, that is going to go to the bottom of the fraction. So if I have 25 to the negative 1/2, well, look what happens. 25 goes to the bottom. I end up with 1 over the square root of 25. And luckily, the square root of 25 is something easy, like 5, so I don't have to worry about having square roots on the bottom. A to the m over a to the n. Make sure the a's are the same, like 3 and 3. So you have 3 to the 5/2 over 3 to the 1/2. I take the bigger fraction, subtract the smaller one. 5/2 minus 1/2 is going to leave me with 4/2, or 2. This m, whoop, whoop, goes to both of them. So 27 to the 1/3 power happens to be 3, and 8 to the 1/3 power happens to be 2. Excellent. Let's take a look how that actually works in the real world in some of these examples. In example 1, 9 to the 1/2 times 9 to the 3/4. Well, I have 9 to the 1/2 power plus 3/4 power. Well, the biggest problem here is adding those fractions up. Maybe using the fraction button on your calculator, or turn them into decimals and back to fractions, whatever you want to do. But if I take 1/2 and make it fourths, it ends up being 2/4. So I get 9 to the 2/4 plus 3/4. I end up with 9 to the 5/4 power. 9 to the 5/4 power. And there's nothing special about that, so I just leave it 9 to the 5/4. When I take a look at this next one, I could do whatever works on the inside, or I could go whoop whoop, or whatever you want to do first. It's really up to you. I might do the work. I might do this. I might go whoop, whoop, because there's really not a lot of work done on the inside because the bases aren't the same. I got 7 and 5. So 2/3 times 3 is just 2, so that ends up being 7 squared. And 5 to the 1/6, well, that times 3 ends up being 3/6, or 1/2. So I end up with 7 squared times 5 to the 1/2 power. And 7 squared times 5 to the 1/2 power isn't really anything magical, so I end up with 49 times either the square root of 5 or just 5 to the 1/2 power. Either way is fine with you. So 49 squared roots of 5 would be a fine answer on that one. This one, they do have the same bases, but I have 3 to the 5/6 over 1/3. Well, it's hard to combine those fractions. So really, it's 3 to the 5/6 minus 1/3. Well, I have to have a common denominator to combine those fractions. So I'm going to call it 5/6 minus 2/6. And if I do 5 to the 5/6 minus 2/6, that's 3/6 or 1/2. So I end up with 3 to the 1/2 power. 3 to or the square root of 3, either way. Know that that's a 1/2 there. On this next one, I'm going to take the 4 to the top and to the bottom, and we're multiplying those things. So I end up with 16 to the 8/3 over 4 to the 8/3. All right, they're both to the same power. Well, there's a lot of things I could do with that. What if I called it 16 over 4 to the 8/3 power? Could I do that? Sure. All right. 16 divided by 4 is 4, so I end up with 4 to the 8/3 power. That's just one way to do it. There's a lot of ways to go about that same thing. Properties of radicals. This one just simply says if you have the nth root of a times b, it's the nth root of a times the nth root of b. And this one is the nth root of a over the nth root of b. All right. Let's take a look at example 2 down there. In example 2, and you guys are going to be doing a checkpoint about this same thing in just a moment, so I'd be ready. In example 2, I have something that looks like this. Well, it says you can combine those things. It's just the opposite of what we were doing there. It's going the reverse direction. 27 times 9, 180 plus 63 is 243. I think that's about right. And if I take the 5th root of 243 on my calculator, what I'm going to find is it is just 3. That makes my life a lot easier. I know some of you said, well, what if I just put it on my calculator in the beginning? Well, you get a decimal and you get like 2.99. You have to be smart enough to know what you're doing there. 192 over 3 is really what I have here. That ends up being the cube root of 64. And the cube root of 64 is just 4. So you guys go ahead and do checkpoint number 1 and 2. See how that goes. Pause the video and work on it. All right, welcome back. Well, I would probably do, I might take this and make it a big number, or, you know, there's a lot of choices. I guess because it's to the 1/6 power, that might make my life a little easier. If I take the 1/6 and I multiply it by that 6 and that 6, remember it's negative. So it ends up being 6 to the -1 times 5 to the -1, which is 1/6 times 1/5, which is 1/30. Now you may have done that a couple of different ways. As long as you ended up with 1/30, you're good. And on this one, I can do 245 divided by 5 is going to give me, I think, the square root of 49. And if I get the square root of 49 equals 7. I will tell you this. I know some of us are putting that on their calculator and coming up with those right answers. That's good. But eventually they're going to be letters, and you know it's that whole thing. You got to walk before you crawl, and crawl before you. You got to crawl before you walk, and walk before you run, right? So let's take a look at example 3 here, and you got another checkpoint coming up. Be ready for that. The 5th root of 128. Well, there's a perfect 5th root inside of 128 that I don't know if you saw, but it was 32. So if I do the 5th root of 32 times 4, well, the 5th root of 32 is 2. That's a real tough one to see. And the 5th root of 4 is nothing special, so it ends up being 2 times the 5th root of 4. and that's a pretty tough one to see, I think, for most students. If you take a look at this next one, we have 2 of these things plus 12 of these things. 2 of these things plus 12 of these things. Well, there's some ways to look at that. If I do 2 of those things times 12 of those same things, it's really 9 of those things. When I talk about those things, I'm talking about the 12 to the 2/3 power. And you just have to see that. It's really all I'm getting at with that question there. And on this next one, we have the 4th root of 48 minus the 4th root of 3. Well, are there any 4th roots that you know that are inside of here? Well, actually, I do know one. I know the 4th root of, or 2 to the 4th power is 16. So this ends up being the 4th root of 16 times the 4th root of whatever's left over, 3, minus the 4th root of 3. You kind of see where this one's going. 4th root of 16, I have 2 4th roots of 3. 4th roots of 3 minus 1 4th root of 3. Well, 2 minus 1 is 1 4th root of 3. And that's, I don't know. That's a pretty tough question there, I think. Let's take a look at this checkpoint. The cube root of 5 over the cube root of 9 doesn't look bad, but the problem is I can't have the cube root of 9 on the bottom of a fraction. So I can do the cube root of 5 on the top. When I do the cube root of 9 on the bottom, I have to multiply the top and the bottom by the cube root of 9. Okay, cube root of 9. And I end up with the cube root of 45, all right, over 9. Because the cube root of 9 times the cube root of 9, oh, I'm sorry. No, the cube root of 9 times the cube root of 9 doesn't do much for me, does it? It ends up with the cube root of 81. And the cube root of 81 is not a perfect cube. So that kind of created a problem, didn't it? So that didn't work out so well. So that was my first thought. My other thought on solving that problem would probably be to work myself, maybe multiply this by something so I can get a perfect cube root. So over here, let's do that. Let's call it the cube root of 5 over 9. And what if I multiply this by top and bottom, 3 times 3? And you see what that gives me. It gives me 15 on the top and 27 on the bottom. And if I take the cube root of 15 and the cube root of 27, I end up with the cube root of 15 over 3, and that's a much better answer. So this didn't help me. This was the way we were doing it before, but now I got to start kind of thinking this way right here. All right. Awkward. 6 times the 4th root of 6 plus 2 times the 4th root of 6. Well, that's going to be 8 times the 4th root of 6. And the 4th root of 6 is really nothing special, so you just leave it just like that. All right. Let's take a look at example 5. In example 5, we have the 5th root of 32x to the 5th. Well, I'm going to call it the 5th root of 32, which is 2, and the 5th root of x to the 15th. Well, what you do in this situation is you do 15 divided by 5. So you end up with 2x cubed. 15 divided by 5 is how you do that. Another way to think about it is if I called it the 5th root of x to the 5th times the 5th root of x to the 5th times the 5th root of x to the 5th. Let's take a look at part B here. If I take the square root of all these things, if I take whoop, 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 and I have this is 6 squared, so I have 6 m squared n to the 5th power. And so maybe you can see that one. if I take the cube root of these things, that ends up being a to the 9 over 3 on top and b to the 6 over 3 on bottom ends up being a cubed over b squared. And look at this monster. What I like to do with these ones is I like to break them into all the different parts. So 42 divided by 6, 7. X to the 4th over x to the 3 halves. Well, x to the 4th is really 8 halves minus 3 halves would be x to the 5 halves power. And y to the negative third, well, that's going to put the y to the top and make it y to the positive third. And z to the 7th over z to the 5th, 7 minus 5 is z to the 2. And so I know it looks tough, but if I broke it into like all those pieces, each individual part, it might be a little bit better. I know that was kind of ugly what I just did there, but maybe you get the right idea. So let's take a look at example 6 here real quick. Let's see how we're doing. We got some checkpoints coming up. Got to be ready for that. See, this is b to the 6th, and what I want to do with b to the 6th is I want to make it b to the 8th, so 4 goes into 8. So I'm going to multiply the top and the bottom of this thing by b squared. And so a squared times b squared, and then on the bottom I have b to the 8th. So I'll end up with the 4th root. I'm going to do it over here so I have some more space. The 4th root of a squared b squared over the 4th root of b to the 8th power. And that was a trick I did so that the 8 divided by 4 would be b squared. So on the bottom I end up with b squared, and on the top I end up with the 4th root of a squared, b squared. All right, hopefully that helps you. In example 7 here, they have 10 times the 5th root of y and 6 minus 6 times the 5th root of y. Well, that ends up being 4 times the 5th root of y, and that makes it pretty manageable, I think. If you take a look at part B, these are all the same thing, I believe, and these are all the same thing. So I'm going to call this 3 plus 4 is 7 times a squared b to the 1/4 power. All right. You guys are going to do this checkpoint real quick, and I'll give you the answers on it. You guys are going to do that checkpoint at home, though, and hopefully you come up with 2x squared y z to the 3rd and an xz squared left over. Xz squared left over inside of the cube root. So that cube root is... Kids are entering back to class right now. Sorry about that. And the answer to this one is 3a times the cube root of 2a squared. So if you didn't get those, we'll talk about that tomorrow. Thank you very much, and have a great day.